Brian Cox, renowned physicist and science communicator, has issued a chilling warning about a mysterious phenomenon surrounding Betelgeuse, the star best known as Orion's shoulder. According to Cox, recent observations have revealed a peculiar dimming in the star's brightness, an occurrence that could signal something truly weird happening deep in the heart of this massive stellar object. But what is causing Betelgeuse's strange behavior? Could this dimming be a prelude to the star's final moments before it goes supernova? Or is this just another cosmic enigma, waiting to be unraveled? Stay with me as we delve deeper into the mysteries of the universe. When it comes to celestial bodies, size matters, and Betelgeuse is a titan among stars. Betelgeuse, a strikingly reddish star, isn't your average celestial body. Its brightness wavers between plus 0.0 and plus 1.6, making it the most luminous first-magnitude star in the night sky. But here's the kicker, it's not just its luminosity that sets it apart, it's also its size. The immense size of Betelgeuse is truly mind-boggling. If it were to replace our Sun at the center of the solar system, its radius would stretch far beyond the orbits of Mercury, Venus, Earth, and Mars, extending well into the asteroid belt. To put its colossal dimensions into perspective, consider this: if our Sun were reduced to the size of a ping-pong ball, Betelgeuse would be a massive structure just like a football stadium. Wrap your head around that for a moment. Now, let's talk mass. Betelgeuse's weight varies, but it's somewhere between slightly under 10 to a little over 20 times that of our Sun. As for its distance, well, that's been a bit tricky to pin down precisely. Estimates suggest it's somewhere between 400 to 600 light-years away from us. Quite a range, isn't it? At less than 10 million years old, Betelgeuse is a cosmic youngster. But don't let its youth fool you, it's evolved rapidly due to its hefty mass. Scientists predict it'll meet its grand finale with a supernova explosion, likely within the next 100,000 years. When that happens, brace yourself, Betelgeuse will shine as brightly as the half-moon for over 3 months. But here's the comforting part: Earth will remain unharmed. We will shed more light on this soon. So, relax. Now, here's where things get even more intriguing. Betelgeuse isn't one to stay put. Nope, it's a runaway star that's been kicked out from its cozy birthplace in the Orion OB1 Association, the same neighborhood as Orion's belt stars. It's zooming through the interstellar medium at a mind-boggling speed of 30 kilometers per second, leaving behind a bow shock over 4 light-years wide. Back in 1920, Betelgeuse snagged another title, the first extrasolar star whose photosphere size was measured. Since then, astronomers have been busy studying its apparent size, which ranges from 0.042 to 0.056 arcseconds. But why the range? Well, blame it on Betelgeuse's quirks. It's not perfectly spherical, and its appearance changes at different wavelengths. Now, let's talk about Betelgeuse's entourage. It's not alone out there. It's enveloped by a sprawling asymmetric envelope about 250 times the size of the star itself. This envelope is a result of Betelgeuse shedding mass over time, creating a captivating celestial spectacle. And guess what? Betelgeuse's apparent diameter, as seen from Earth, is surpassed only by a couple of other stars, our Doradus and, you guessed it, our very own Sunday. But there's still so much more to uncover about this enigmatic star. Betelgeuse isn't just any old star, it's a behemoth in the cosmic arena. Classified as an M1-2 Ia red supergiant, its designation reveals a lot about its nature. The EM signifies its red hue and relatively cool temperature, while Ia denotes its intermediate luminosity, placing it between a typical supergiant and a luminous one. Since 1943, Betelgeuse's spectral fingerprint has been a stable reference point for astronomers classifying other stars. Pinpointing Betelgeuse's exact luminosity is no easy feat, thanks to uncertainties surrounding its surface temperature, diameter, and distance. However, recent studies estimate its luminosity at around 126,000 times that of our Sun, assuming it's about 200 parsecs away. Temperature-wise, Betelgeuse is a bit of a chameleon, with readings ranging from 3,250 to 3,690 Kelvin, fluctuating due to atmospheric pulsations. But here's where it gets even more fascinating. Betelgeuse isn't one to rush. it's a slow rotator compared to its stellar counterparts. Clocking in at a leisurely 5.45 kilometers per second, it's a snail's pace compared to speedier stars like Antares. It takes Betelgeuse a whopping 36 years to complete a single rotation, tilted at an angle of about 60 degrees to Earth. In 2004, astronomers hypothesized that despite its sluggish rotation, Betelgeuse might still boast significant magnetic activity in its expansive atmosphere. This magnetic influence could sway everything from its dusty shroud to its stellar winds and mass loss. Fast forward to 2010, and observations using the Bernard-Lyot telescope at Pic du Midi Observatory confirmed the presence of a weak magnetic field at Betelgeuse's surface. This discovery hinted at the colossal convective motions within supergiant stars, sparking a miniature dynamo effect. Betelgeuse's journey through space is a cosmic puzzle, with its kinematics posing more questions than answers. Class M supergiants like Betelgeuse, born with an initial mass of around 20 times that of our Sun, typically clock in at around 10 million years old. But here's where things get intriguing. Tracing Betelgeuse's path backward in time places it in an improbable location, far from any known star-forming regions. It's as if it took a detour through uncharted cosmic territory. What's more, Betelgeuse's trajectory doesn't seem to align with known stellar hotspots like the 25 Ori subassociation or the Orion Nebula cluster, despite their relative proximity. This begs the question, has Betelgeuse always followed its current path, or did it veer off course at some point? Some astronomers speculate that a nearby stellar explosion might have nudged it onto its present trajectory. A revelation from the Herschel Space Observatory in 2013 added another layer to the mystery. Betelgeuse's mighty stellar winds are colliding with the interstellar medium, creating cosmic shockwaves in their wake. But where did Betelgeuse come from in the first place? The prevailing theory suggests it's a runaway star from the Orion OB1 association, once part of a high-mass multiple system within Ori OB1a. Born roughly 10 to 12 million years ago, Betelgeuse's journey has been anything but ordinary, fueled by its massive bulk. However, an intriguing proposition emerged in 2015, suggesting that Betelgeuse might belong to the newly unearthed Taurian OB association, adding another twist to its stellar saga. In 1998, radio telescope images unveiled the complex nature of Betelgeuse's atmosphere, revealing a complex interplay of gases with temperatures hovering around 3,450 Kelvin. Surprisingly, this gas was cooler than the surrounding region, challenging astronomers' preconceptions about red supergiant atmospheres. Instead of a uniform expansion driven by high-temperature gases near the surface, Betelgeuse's atmosphere showcased colossal convection cells, propelling gas outward from the star's surface into its surroundings. This discovery reshaped our understanding of stellar atmospheres, highlighting the dynamic nature of these cosmic giants. And that's not all. In 2009, a bright plume, possibly laden with carbon and nitrogen, was spotted extending from Betelgeuse's southwestern direction, hinting at intricate chemical processes unfolding within its fiery depths. But Betelgeuse's mysteries extend beyond its atmosphere, delving deep into its chromosphere and the shroud of dust enveloping it. Thanks to the faint object camera aboard the Hubble Space Telescope, astronomers caught a glimpse of Betelgeuse's chromosphere in ultraviolet light. What they found was fascinating. A bright patch in the southwest quadrant of the star's disk, hinting at dynamic activity within. Back in 1996, the chromosphere's average radius was estimated to be about 2.2 times the size of the optical disk, roughly 10 astronomical units, AU. Its temperature hovered around 5,500 Kelvin, revealing a region of intense energy and activity. However, further observations in 2004, using Hubble's STEES spectrometer, uncovered warm chromospheric plasma extending up to 1 arcsecond away from the star, potentially reaching a staggering $200 in size at a distance of 197 parsecs. This revelation showcased the struggle between hot plasma and cooler gases within Betelgeuse's gaseous envelope, alongside the dust particles swirling in its circumstellar dust shells. But Betelgeuse's cosmic cloak doesn't end there. The first hints of a dust shell surrounding the star emerged in 1977, when astronomers noticed excess radiation emitted from positions beyond 12 stellar radii. This radiation, typical of mature stars, suggested the presence of a dusty veil surrounding Betelgeuse. Subsequent studies using heterodyne interferometry confirmed this, pinpointing the dust shell's inner radius at around 100 to 200 Australian dollars, or 0.5 to 1.0 arcseconds. Yet, the story doesn't stop at Betelgeuse's dusty attire. Studies conducted in the 1980s revealed complex spectral lines originating from circumstellar gas, indicating multiple gaseous shells enveloping the star. One of these shells, positioned about 0.5 arcseconds away from Betelgeuse, appeared to be composed of pure gas, with the possibility of a more distant dust shell emerging as the gas expands and cools. Despite these groundbreaking findings, the spatial orientation of these structures remained a mystery. In 2009, infrared interferometer observations using the VLTI at the Paranal Observatory provided fresh insights into Betelgeuse's circumstellar environment. The data confirmed the existence of asymmetric structures within the star's dusty veil, supporting the presence of intricate dynamics and processes shaping its outer layers. Betelgeuse's cosmic journey continues to captivate astronomers, offering a glimpse into the ever-evolving nature of massive stars and the mysteries they hold. In December 2019, Betelgeuse's unexpected dimming sent shockwaves through the astronomical community. Dropping to a visual magnitude of 1.5 by February 2020, this marked its lowest light output in over a century, sparking global speculation about a potential supernova event. Dubbed the Great Dimming, this anomaly was attributed to extensive dark spots covering up to 70% of Betelgeuse's surface and a dust cloud formed by cooled plasma expelled from the star, partially blocking its light. Normally the 10th brightest star in the sky, Betelgeuse's dimming altered Orion's iconic appearance, briefly elevating Bellatrix to prominence. However, by May 2020, Betelgeuse began regaining its brightness, reaching magnitude 0.4 in August and stabilizing at around 0.5 by mid-2021. During the Great Dimming, astronomers and observatories worldwide conducted an unprecedented observational campaign. In April 2020, a European Southern Observatory team released images from the Very Large Telescope, revealing significant surface changes. Hubble Space Telescope's ultraviolet observations unveiled dense, heated material moving from the star's surface, triggering a subsequent cooling event that formed dust, partially obscuring Betelgeuse's southern hemisphere. The Strapple polarimeter at the astronomical station Vidojevika in Serbia noted changes in the degree of linear polarization, indicating intensified mass loss and evolving dust shell properties. In 2021, the Event Horizon Telescope, renowned for imaging the M87* black hole, turned its attention to Betelgeuse to decode the dimming mystery, capturing unprecedentedly high-resolution observations. Betelgeuse, with its enigmatic behavior and celestial grandeur, continues to fascinate astronomers and stargazers alike, offering a dynamic window into the life cycles of massive stars and the cosmic forces that shape them.